Welcome to Chem 1114 at SMU. Today we'll be doing the technique lab. I'd like you to be my partner. The first thing that we're going to do in part 1 is to read and record the barometer. We're going to be reading the middle red scale, which is millimeters of mercury. The smallest divisions of this scale is 1 millimeter of mercury. So that means we'll read to the 1 and estimate to the 10th. Let's read this barometer reading. I'd like you to read and record it. It should have 4 significant figures when you're done. You can read the important information in the box to the right of the conversion factors. The conversion factors are all exact numbers, which have an infinite number of significant figures. Therefore, the number of significant figures in a converted value will be dependent upon the number of significant figures in the barometer reading. I'll do an example conversion. One of the unit conversions we are not using in the technique lab is 1 atmosphere is equal to 1.01325 bar. I'll convert a pressure reading of 751.8 millimeters of mercury to bar using dimensional analysis. You can follow along in the slide. The final pressure will have 4 significant figures since the original pressure reading had 4 significant figures. Do not base the significant figures on the conversion factors. Please complete the barometer conversions in part 1 using dimensional analysis. In part 2, we're going to read and record the thermometers. We have 2 different thermometers. This one goes from about -20 to over 110. The smallest markings are 1 degree, so we'll read to the 1 degree and estimate to the 10th. I'd like you to read this thermometer. The other thermometer is the 0 to 50 degrees Celsius thermometer. The smallest markings here are in the 0.1 degrees Celsius. So we'll read to the 0.1 degrees Celsius and estimate to the 100th. I'd like you to read this thermometer. I'd like you to answer the next 4 questions, paying attention to the significant figure help in parentheses. A percent error is a numerical value stating how far a value is from a known or published value. You can either express it as an absolute value or as a positive or negative number. When you do express it as a positive or negative number, this can give the direction that the experiment needs to be changed or the value needs to be changed so it can be closer to the known value. Let's look at the significant figures here. I'll give an example and you can calculate the percent error from the data we've collected. In this example, let's assume we observed a freezing point of 31.62 degrees Fahrenheit for water. The percent error formula is given, and you can calculate the percent error from that. Note that the top number has 2 significant figures based on subtraction significant figure rules. The bottom significant number has 4 significant figures. Therefore, the final answer in this example should have 2 significant figures. Complete the last question in this part. The last part that we'll be doing in this technique lab is we're going to be calibrating a pH meter and then titrating acetic acid with sodium hydroxide measuring the pH. So the first thing I need to do is calibrate the pH meter. So I'm going to plug it in. And then I'm going to remove the protective cap for my probe. And then I'm going to hook up the electrode, the pH electrode, to this meter. This one actually has a temperature control too, so I'll plug that in. And in this bottle, I have an electrode. A fun fact here is that this is a potassium chloride solution, the last step in the lethal injection process. Please do not inject it. So I'm going to first clear any entries out, and then be sure that it's set to 2 of the pHs that I'm going to use, and this has 2, 4, 7, 10. I'm going to be using a 4 and a 7 buffer to calibrate this meter. And then I'm going to normalize the electrode, and that's just rinsing the electrode with a little bit of the solution. I'm going to just pour some over, shake it off, and let the pH electrode sit in the pH 4 solution for a little while until I get an S in my display, which I had it, here's an S. And then once I see that, I'm going to hit standardize. And I'll know it's done when I see a small 4 at the bottom of my display. I'm going to do the exact same thing with the pH 7 buffer solution. Pour a little bit on to normalize it, shake it off, and then lay the electrode in the solution. When I see the S again, I'll hit standardize. And then I'll hit enter when I see the 7 at the bottom. Now our pH meter is calibrated. These instructions are also in the lab manual. The next thing we'll do is normalize our burette with the sodium hydroxide solution that will be delivered during our titration. You might want to make a note of the molarity of this sodium hydroxide solution. Now remember, normalizing is coating all of the inside surfaces of the burette with the solution that we'll be using. So we'll remove this clean burette, upside down, tip up, stopcock open. We'll close the stopcock and add a little bit of the solution. And just kind of roll it around, coating all the inside surfaces. And then you can drain it to the drain through the stopcock. And I'll close the burette, put it back in the burette clamp, and now I'll fill the burette with the sodium hydroxide solution above the 0 mark. And it's not going to be above the 0 mark. I don't have enough solution. That's okay. But I'll just drain a little bit now, just to make sure that the solution goes through the tip. I'd like you to read this initial Burette reading. Next, I'm going to dispense some acetic acid, and you can note the molarity here, to my 250 milliliter beaker. I'm going to titrate into this beaker. So first I'm going to place my waste beaker underneath and gently lift up on the barrel. If there's a drop of waste, that can be put in the waste beaker. Then I'm going to put my titrating beaker underneath and gently press to dispense 50.0 milliliters of acetic acid. Now I'm just going to blot the end of the pH electrode with a paper towel just to get that pH 7 solution off of it. And then I'm going to insert it into the acetic acid that we've put in our beaker. And I'm going to let that stabilize a little while, probably 2 to 5 minutes, so that the pH reading is very stable. Now that our pH has stabilized and we've read our initial reading, I read it as 9.25 milliliters, and our initial pH is 2.74. So in your recording, I'd like you to read 9.25 at the very, very top in this bold box right here. Now this is important because we're going to be subtracting this value from each one of these when we calculate this middle column. So right now you should have 9.25 and 2.74 as a pH. I'm going to drain it in about 1 milliliter increments. It doesn't make any difference how much that needs to be exact, but it just makes everything go a little bit more smoothly. And then I'll use my electrode as a stirring rod, and I'll read it. At 10.35 milliliters, and my pH is 3.58. I just drained another about 1 milliliter, so let me read that and the pH. The reading is now 11.25. And my pH reading is 3.90. I'll drain another milliliter. The reading is 12.48, and the pH reading is 4.14. The reading is 13.32, and the pH is 4.27. The reading is 14.25, and the pH is 4.42. The reading is 15.45, and the pH is 4.58. The reading is 16.25, 20.25, and the reading is 4.69. The reading is 17.20, and the pH is 4.83. The reading is 18.35, and the pH is 5.00. The reading is 19.20, and the pH is 5.15. The reading is 20.42, and the pH is 5.43. The reading is 21.25, and the pH is 5.71. The reading is 22.35, and the pH is 8. I'm going to let it stabilize here because we're right at the equivalence point. We're very close to it. However, we're going to read to a pH of above 12. This might take a while as it continues to drop. You rarely hit it right at the equivalence point or right on the sharp jump of the curve. Okay. And it's stabilized at 7.54. That's 7.54. I'm going to drain another milliliter. The reading is 23.25. And again, I'm going to wait for this to stabilize. We're at a very high pH now, almost done with the titration. .78. That's the pH, 11.78. We need to go to 2 readings above 12. And the Burette is reading 24.42. The pH is 12.02. One more and we should be done. I'm going to lift my Burette a little bit to read it better. 25.30, and the pH is 12.24. We're done with this titration. Now we're going to do 2 things. First of all, we're going to completely drain this Burette we need to rinse it with DI water, flip it, and leave the stopcock open, signifying it's a clean burette. When you have recorded everything, you need to make a graph. The pH should be on the y-axis, oriented landscape, and the milliliters of NaOH added should be on the x-axis. Give your graph a good title. Go to experiment 15 to look what a good title might look like, and graph your data in a smooth set of points. And now I'm going to fill this up completely and let this drain. And be sure to put the pH electrode back in its container, and the electrode must remain upright so the bulb of the electrode is wet with the KCl solution. We're done. Thanks for being my lab partner.